Hello everyone, welcome back to Pharma Solution. If you're new to this channel, my name is Joseph and I am an electronic enthusiast. So I will want us to simulate a little circuit today. This is a double pulse test circuit, DPT circuit, for testing the losses of a particular transistor, which we have chosen today, an Infineon power transistor. This transistor can hold a voltage of about 600 volts and above. So this particular transistor is a power transistor applicable in power systems, maybe like in renewable energy, power converters, and all the like. So the package of this transistor is the IHW20N120ROS. Actually, this transistor model is not available on LTSPICE. As you can see, we are using the LTSPICE simulation environment to simulate this circuit. But when you look at this particular transistor is not found in LTSPICE. So what you have to do is to get it from Infineon. This is an Infineon SPICE model. So you need to go to Infineon and you download this particular simulation model and you include it in LTSPICE. And I would like you to watch my videos to see how to include this symbol from the Infineon simulation model into LTSPICE for your simulation. So you can easily download this from Infineon. You just have to type this particular package, which is the 1H.L1, and click enter. And so there you can get it from Infineon. You go down here, this is Infineon. So from there, this is the data sheet. You can click here and download the data sheet. And then for the simulation model of that particular transistor, you can get it, I think somewhere here, or better still, you can go to resources. And when you go down here, you see simulation models. You click on simulation models and you download this second one. You click here and you'll be able to download the simulation package. It's a zip file. Yeah. So from there, I will show you in the next in my video. You can go through the video. You will see how to include simulation model from producers of particular power transistors into LTSPICE. So this circuit have been built and we have our inductor and a very small resistor and our diode here. This diode is just an ideal diode. And we have our pulse. So the pulse here have been set to be when you right click on this. So for you to set this pulse at the gate, you need to right click on this voltage source and then you click on pulse here. There you can set the initial voltage based from the data sheet. The initial voltage is 0. The maximum voltage is 15 volt. You can put 15. So from the data sheet, so since it's a double pulse test, we need to put 2 cycles here. So I put 2 cycles. You can also set yours according to my own settings here. Yeah. And then you click OK. So we are going to run this. Remember, the input voltage into this is 600 volts. So this is a power transistor, a high voltage. It deals with high voltage. So we are going to simulate this. You click on the play button here. Yes. So now let's partition this simulation, the waveform window, the oscilloscope, into 2. I'll right click on this and I will go here, add plot pan above. I left click. So 2 oscilloscope will appear here. 1 I want to use to view the voltage, and 1 I want to use to view the current. So now let's look at the voltage, the pulse that is going to the gate. So first I will go here and click here, left click here to the point where I want to view I want to place all my voltages. So I will click here at this upper plane and then I bring my mouse to the gate. I'll click at any point here on this schematic, and then I bring my probe where I want to measure the voltage. So when it touches the line, I click, and there we can see, since a double pulse, and I've set it at a very high frequency of about 100 kilohertz. So you need to come here and zoom. This is a pulse here, it's a pulse. So zoom it. Remember, it's at a high frequency. So I need to zoom, you see how it is coming. So this pulse, I remember we set it at 15 volts. You can see here, 15 volts. So it is here 15 volt, the first second, double pulse. Yeah. And then next, we are going to look at, let's see the input voltage here. We click here. You can see it at 600 volts, the blue line, VN01, 001, and VN004, which is our gate pulse, and then our input voltage, which is 600 volts. Okay, next, let's look at our currents. I will click here, left click here at the bottom plane, and then I want to measure the current that is going through the transistor. I will come back here at the schematic, click, and then I will put my cursor until the ammeter, the clamp meter appears. Then I will click. This is a waveform of my current, and this current is about 30 ampere that is flowing through this transistor. So the transistor is carrying the current of about 30 ampere through it, 30 ampere and above when you look at it very well. So let's look at the current through the inductor. Of course, the current through this inductor will follow the current through the inductor. So let's click the inductor. Of course, you see it. So in the beginning, when the voltage is supplied at at this terminal, the inductor current starts building. At the same time, current will be flowing through this transistor. So the current will be flowing like this through the transistor. So the inductor current from this 0 microsecond to 6 microsecond, you see the current starts from 0 and it increases to about some 15 ampere. And then when this transistor goes off, what happens is that this current that is stored in this transistor loops within this freewheeling diode. It loops in this loop. So at that point, the current remains constant at 15 ampere while the transistor is off. Okay? So at that time, no current is going through the transistor. You can see the transistor current has gone to 0. No current is going through it. And then in the second pulse, look at it here. When the transistor comes on, it doesn't start from 0. The current doesn't start from 0, you see. It picks back the current that was stored in this loop. It takes it from the 15 volts from here and then starts increasing right to about 30. From 30 ampere, sorry. It picks the current from 15 ampere and it increases right up to 30 ampere, and then the pulse is done. Remember, we have just set this system to operate on 2 pulse, so it's a double pulse test. So with that, I would like us to measure our energy, the energy lost during the switching on and off of this transistor, which is very important for double pulse testing of a transistor. Remember, double pulse testing of a transistor is to determine the switching losses and the conduction losses of that transistor. And usually, according to the data sheet, you need to compare what you have with that of the data sheet, because in this data sheet, when you follow all the conditions that are prescribed in the data sheet, the switching losses, the turn-off losses of this particular transistor, as you can see, the energy loss when the transistor goes off is about 0.75 millijoules. So when you follow all of these conditions, so I would like to measure that energy loss at this upper part of it. So what you will do is that You click here at this plane where you want to measure your energy, where you want to place your energy, and then you come back to the schematic, you left click, and then you press your Alt button of your keyboard, press it, and then bring your cursor to the transistor until this thermometer symbol appears, and then you left click. Very good. You see the energy spikes, the power spikes, sorry. So from these power spikes, you'll be able to measure the turn off and the conduction and the turn on losses, beginning with the turn on, conduction, and turn off losses. So where does the transistor comes on? Let us take this interval. So the transistor goes off here, it comes on here, and goes off here again. So let's take this interval of this pulse for the second pulse. So this is where the transistor comes on. So when it comes on, you can see this mighty spike, the power spikes. So we are going to zoom this power spike. From there, we'll be able to measure the turn on energy loss. And then at turn off, you need to zoom this other power spike to measure the turn off energy loss. So let's start with this one. We'll zoom it. You zoom it by pressing left clicking your mouse, sorry. Left clicking your mouse and then pulling this square such that the spike can be very much visible. So that is it. So for us to measure this energy loss, let's try to magnify this. Okay, very good. So let us make this more visible. This is a turn on energy loss. The turn on energy loss is simply the area under this graph, the area under the power spike, just this entire area. So there, to easily measure that, I will show you one simple way of doing it. So first, you go here to where the multiplication has been done. You right click, sorry, on it. And then you go to here, attach cursor, take 1 and 2, 1 and 2. You click OK. Now you'll be able, you bring your mouse here until 1 appears. You take this grid to this point where you want to start your measurement, your reading. And then you come to this other grid, you take it to this other point where it ends, where you want to take a reading. And then you press your control button of your keyboard and left click on this calculation here. There you have your energy, which is 365.06 microjoules. So this is the turn on energy loss of the transistor. So the LTSPICE automatically does the calculation and gives you. So this is about 0.365 millijoules of energy loss. Okay, now let's look at the turn off energy loss. Or before that, let's look at the conduction losses. Sorry. Okay. Now, this is a point when the transistor is conducting current. So from this interval, where it comes on right up to the time when it goes off, is the conduction interval. So from this point to this point, here you'll be able to measure the conduction losses. So you can zoom. So from here to here, we do the same thing. You right click, take 1 and 2, you click OK. You bring your mouse here, you left click and pull this towards this end. You bring the mouse again, you left click and pull this towards this end. Good. And then you press the control button of your mouse. First, bring your mouse cursor here and press the control button of your keyboard and then left click on this calculation. There you see The conduction energy loss is in millijoules, 1.8697 millijoules. Good. Next, we are going to calculate the turn-off energy loss. Okay, sorry. So the turn-off energy loss, you zoom this spike where the transistor turns off. Zoom it. Zoom it. This is a bit tricky, to measure. Okay. All right. So I will then take this, do the same thing. 1 and 2. Okay. I'll pick this. When it shows 1, I left click, pull it. I place it here. And this other one, I left click, pull it. I want to put it here. It is not to scale, it's just to see what we want to see. Okay, next you left click. You press the control button of your mouse, first. Press the control button of your mouse and you left click on this. You see the energy is 1.2365 millijoules. 1.2365 millijoules, the turn-off energy loss. Yeah, 1.2365 millijoules. All right, so that is it for today. I just wanted to show you how to carry out DPT testing of this particular transistor, and this holds for many other majority of the transistors that we have outside there. All right, thank you very much and see you in the next video.